Good day, students. In this clip, we're going to be going over some examples reviewing the resolution of vectors. So let's take a look at the first example. It says a force of 65 pounds acts on an object at an angle of 30 degrees. A second force of 70 pounds acts on the same object at an angle of negative 55. In a sketch of this situation and resolving the vectors, let's go over some formulas real quick. Let's say I have a force F, and I wanted to express this force in a component form. It can be written as a coordinate, so you have F in the x direction, comma, F in the y direction. Okay? How do you find the x and y components of this force? Assuming the direction of the force is theta, then we can simply find the components of this force by evaluating F cosine theta for the x component or the horizontal component and F sine theta for the y component or the vertical component of the force. If you want to find the magnitude of the vector, magnitude of F, the magnitude of F is written as the absolute value of the vector, absolute value notation, but this is known as the norm or the magnitude of the vector. And this can be evaluated using the Pythagorean theorem, where the a and b are the x and y components of the vector. So f of x squared plus f of y squared. If you want to find the direction theta of f, the direction is simply the inverse tan of the y component divided by the x component. If you think about SOHCAHTOA, tan is opposite or adjacent. So in this situation, this is like the opposite, and this is the adjacent. All right? Okay, let's take a look at the problem now. So it says 65 pounds is acting at an angle of 30 degrees. So what we're going to do is let's assume that the object is sitting on a coordinate system and the object is right on the origin. All right, so let's see. So the first one is 30 degrees and it has a magnitude of 65 pounds. So F1, okay? So we call this F1. F1 is 65 pounds and has a direction of 30 degrees. Remember, when you rotate counterclockwise, it's positive, all right? The next vector is 70 pounds, second force, and is acting at an angle of negative 55 degrees, all right? So it's going to be somewhere down here. Remember, when you're graphing a negative angle, you're going to be rotating in the clockwise direction. All right, so this angle right here is negative 55 degrees, and the force F2 is I forgot, I think it's 70, right? It's 70 pounds, right? So 70 pounds. Okay, now that we have the vector sketched, let's use the parallelogram rule to find the direction of the resultant vector. In order to do that, what we'll do is we're going to just create a parallelogram. Alright, so the resultant vector, after constructing your parallelogram by drawing the two vectors on the tips of the other vectors, this diagonal right here from where the two tails originates, the origin to where the two tips meet, will be your resultant vector. Okay, so this vector right here is going to be, let's call it vector R, our resultant vector, and it is basically F1 plus F2. Alright, F1 plus F2. That is what we are supposed to find. Okay, so in order to easily find F1 plus F2, I'm going to express these two in component form, and then just simply add the components to find vector R. Okay, so let's start with vector F1. F1 is equal to let's write it in component form. 65 cosine 30 degrees for the x component, and 65 sine 30 degrees for the y component. And then F2 is equal to 70 cosine negative 55 for the x component, and 70 sine negative 55 for the y component. Alright, so let's write this in decimal form so it's easy for us to find the sum. Let's use our calculators to find out what these are. So we have, let's see what we have here. And make sure your calculator is in degree mode because our angular measures are in degrees. Okay? Alright, so we're going to start with 65 cosine 30 for our x coordinate of f1, and then 65 sine 30 for our y component of f1. So we have 56.2917, 56.2917, comma 32.5. Now for our y, for vector f2, we're going to do 70 cosine negative 55. Alright, see what that is. And do the same thing, 70 sine, I did the inverse sine, 70 sine negative 55. Alright? And then your answer is going to be negative 57.3406. Okay, so let's write it down. For our vector f2, we have 40.1504, and then the y component of f2 is negative 57.3406. Alright, now to find the resultant vector r is simply going to be f1, vector f1 plus f2. Okay, how do we figure that out? We're just simply going to add these two vectors to each other to get our final answer. Alright, so let's go ahead and compute what the sum is. So to find that out, we're going to do 56.2917 plus 40.1504, and we have 96.4421. Let's write that down. 96.4421. That's the x component of our vector. And then for the y component, let's do that. We're going to have 40.1504 plus negative 57. Actually, let's do that again. We're doing 32.5 plus negative 57.3406. Alright, so that's our y coordinate of the y component of our resultant vector. So that is, let's write that down again, negative 24.8406. Alright, now let's find the magnitude. To find the magnitude of this vector, magnitude of vector r, that's simply going to be done by taking the square root of the x component of vector r squared plus the y component of vector r squared, the square root of the sum of the squares. Alright, so that's simply going to be the square root of the sum of the squares of these two components. So 96.4421 square plus negative 24.8406 square. Okay, let's go ahead and evaluate that. We're going to have the square root of 96. Let's just go ahead and copy down this answer just to save time. So copy that down, square it, square plus this other answer, square, and our answer is 99.5898. Alright, so the magnitude of vector R, the resultant vector R, is 99.5898 pounds. Alright, now let's find the direction. Okay, the direction, let's call it theta. Direction, theta of the resultant vector R is going to be the inverse tan of the y component of vector R divided by the x component of vector R. Okay, so that's simply going to be the inverse tan of the y component right here, which is negative 24.8406 divided by the x component, which is 96.4421. All right, let's go ahead and evaluate what that expression equals. This kind of looks like a 4. Let's fix that. 4421. All right, so if we do compute the quotient in our calculators, we have negative 14.4437 degrees. All right, so theta equals negative 14.4437 degrees. All right, so let's write down the meaning of our answer. What our answer means is that the resultant force has a magnitude of 99.5898 pounds, and a direction of negative 14.443 degrees. All right, so let's apply our answer to our sketch right here. So this is the 99.98. Is that what we got? No, 0.558. 99.58 is the sum of the two vectors, and the direction is right here. The direction is this angle that this vector R has. So this angular measure right here is what did we get? Negative 14 degrees. All right, negative 14.44, I think, degrees. That's the direction of the resultant force. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel so you can get updates to other cool clips such as this. And please post a comment to let me know what you think about this presentation. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.